So if I say okay, you should determine the Fourier series coefficient A sub k's when I give you x of n's, so these x of n's are known and A sub k's are unknown. So how are they simultaneous equations and how would I be able to? Okay, Asna is sort of there. She says same length, same period, same number of equation from each. Asna, can you unmute your mic and talk to me?
Yes, sir.
जी, आप बताइए, I mean, what are you thinking?
Sir, सेम लेंथ होगी, n हमारा इंटरवल सेम होगा, उसमें से सेम नंबर ऑफ इक्वेशंस आएंगे और दोनों का पीरियड भी सेम है. I don't know how to explain it, but
Okay, so let me
इस
just
तरह
very,
से भी
very,
simultaneous.
very quickly say this. I mean, maybe Naveed is going to talk about this further. So x of 0 is something that you know, right? And I just say कि this is x of 0 based on this expression, equation number 1. Okay, x of 0 is just a1 times this is 1 plus a2 plus a3 plus a4 and so on and so forth. Okay, so this is one equation. So x of 0 is summation k equals 1, k equals 0 to n minus 1 a sub k's, right? This is one equation. And then x of 1 is summation k equals 0 to n minus 1 a sub k's e raised to power j k 2 pi by capital N times 1 because small n equals 1. Okay? So this is equation number 1. This is equation number 2. And so on and so forth. So this is x of n minus 1 would be k equals 0 to capital N minus 1. A sub k is e raised by j k 2 pi by capital N times n minus 1. And this would be equation number n. And there are n equations and capital N equations, capital N unknowns. Okay? Or known क्या चीजें हैं? This is known to me. This is known to me. This is known to me. And from these unknowns, I just need to solve these equations somehow. Okay? One of the ways to solve this, I mean, you could use algebra if you want to. Maybe that's what Naveed is going to do. Instead, the approach that we've used here is similar to what we had in the continuous time case as well. Okay? You say, KG, let me multiply my signal x of n with some e raised to minus jr 2 pi by capital N times n, and then sum over 0 to n capital N minus 1. And then I just plug in what x of n here is into this. I get a double summation. Double summation के अंदर ये वाली summation, and I see that this is actually equal to 0 whenever k is not equal to r and is equal to n when k equals r, and dot 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 करते करते this is the final result that you get. And this final result is the analysis equation. Okay, now I'll take a moment here and stop and take any questions you may have. I did get questions over the weekend about why this was true. Okay, and I can try to address that. इसके अलावा कोई और किसी और की confusions, let me see कि जी समझ आ गई सबको ये जिन्होंने देखा था. क्वेश्चन किसी का है या नहीं है? अगर सब समझ आ गई है तो फिर then I'm going to start asking you as well. Okay, चलें, I'll start doing it. Right, so I'm just randomly going to pick a name. Right, so Roshan. So why don't you tell me why this is true?
Sir, कौन सी चीज is true? Oh, okay.
Yeah, ये red pointer आपको नजर आ रहा होगा. Okay. Why is this summation? Why is this summation equal to 0 whenever k is not equal to r? And why is this summation equal to capital N when k equals r? I mean, there's a slight bit of a mistake here as well. लेकिन चले मैं उसको भी ignore कर रहा हूँ. So why is this equal to 0 when k is not equal to r?
Sorry, repeat the way the
J?
so give me a second. I'm trying to understand. I got it when during the lecture review. Right. Basically, when k is equal to r,
Yeah.
we have an exponential with the power of 1 and वो zero और वो फिर 1 हो जाता है.
Yeah.
And from the summation we know that it's going to be 2 to the power n.
No, 2 to the power constant. So this is just 1. Okay, you're right. This is just 1, and you're summing 1 capital N number of times. That's 1.
तो वो n बन जाएगा, and then when it's not equal to r, तो वो हम जब sum करेंगे तब वो 0 आएगा.
क्यों आएगा 0? चलें, ठीक है. Let me ask somebody else. Haris?
जी सर.
Why do you think this is 0 when k is not equal to r?
So जब k r के इक्वल नहीं होगा तो ये एक साइनोसाइड बन जाएगी.
Yeah.
तो विद द पीरियड, एक स्पेसिफिक पीरियड की. तो सो जब उसको सम करेंगे हम तो वो जितनी भी उसकी वैल्यूज होंगी वो कैंसिल आउट हो जाएंगी.
Okay. Okay, good. So an intuitive reasoning here is that it's actually a sinusoid in the real domain and sinusoid in the imaginary domain. ठीक है. और उसको आप जो है एक पीरियड के ऊपर सम करें और इंटीजर नंबर ऑफ पीरियड्स के ऊपर सम करें और वो that I know that's going to sum to 1, sum to 0. ठीक है. You can actually use and let me do that here. A finite series formula here as well. Can somebody do it through a finite series formula? So you say, yeah, what is so summation किसके ऊपर थी? N के ऊपर. What is n equals 0 to capital N minus 1 e raised to power j 2 pi divided by n k minus r times n. What is this equal to? Okay, Jamshed said sinusoid integrating continuous time can sound up in discrete time becomes 0 over 1 period. Okay, that's correct. If I were to do it in this fashion, what do I get on the right hand side? So what I get on the right hand side is, so who's going to help me? Rimsha?
Ji, sir.
What is this equal to?
I don't know what the formula is.
अब तो इतनी बार कर लिए, ये तो याद होना चाहिए. चले, who else remembers? मैं नीचे से आ रहा हूँ, नीचे से स्टार्ट करते हैं. So I can ask Tuba.
Yes, sir.
What is this equal to? If I sum over n.
Sir, I don't remember.
So who remembers? Can you raise your hand? Ji Zara, go ahead.
Sir, so the exponential raised to power j 2 pi by n and k minus r will actually be the ratio r. So we can do 1 minus r raised to power n divided by 1 minus r.
So r is e raised to power j 2 pi. So actually r से मुराद आपकी ये वाला r नहीं है जो मैंने लिखा हुआ. So you're just and this raised to power the number
capital N.
Capital N, and this is 1 minus e raised to power j 2 pi by n k minus r. ठीक है. अच्छा, और किसको याद था? हसन ने भी, I saw Hasan raising his hand as well. He remembers as well, right? अच्छा, so how is this equal to 0? जी हारिस. अच्छा, चलिए आपसे मैं पूछता हूँ. Haris raised his hand. Haris, why is it 0?
सर सर ये एक्सपोनेंशियल को आप ब्रेक कर देंगे, मतलब e raised to the power j 2 pi over n times k और एक मल्टीप्लाइड बाय e raised to the power j 2 pi over n times r और उसके ऊपर पावर कैपिटल n है तो वो भी बीच में आ जाएगी सर। आई थिंक उसके बाद सिंप्लीफिकेशन करेंगे तो वो 1 minus 1 बन जाएगा तो वो कैंसिल हो गया।
Good. So you see, this cancels with this thing here. So then I have e by j 2 pi, and k is an integer and r is an integer. Okay? And e raised by j times 2 pi times an integer is always equal to 1.
Simply, yes.
So this is equal to 0. Why? Because the numerator is 1 minus 1. Except for what case? There's a corner case here, and that corner case is when k equals r. What happens when k equals r? Hassan, आपने भी हाथ खड़ा किया था. So what happens when k equals r? So 0 is...
So the exponential becomes 0, the 1.
Yeah, so the numerator exponential is still 1. What about the
denominator? So before on the left hand side, when it becomes 1, you're just summing 1 from 0 to n minus 1, which is just n.
ठीक है, लेकिन आप अगर थोड़ा सा आप यहाँ पे आए ना, आपने यहाँ पे कहा कि when k equals r, you're just summing 1 n number of times, so that is equal to n. But this should also be valid, right? And if I see here कि capital N k equals r, so this is still 1 minus 1. Shouldn't this still be 0? Isn't there?
So the denominator also becomes 0. So we'll have to use L'Hopital's rule.
Right. That's excellent, right? So the when k equals r, the denominator also becomes equal to 0. So you may want to apply L'Hopital's rule, or you just go back and see that this is actually equal to n. So this is n when k equals r. अब असल में यहाँ पे थोड़ी सी गड़बड़ है. वो कोई गड़बड़ मुझे बता सकता है? So I'll try to write this a little differently. When k equals r की बजाय ना मैं कहता हूँ when k minus r equals 0. Does this thing hold true for any other values of k and r? क्यों Said?
Yes, sir.
So I say that this is equal to capital N when k minus r equals 0.
Yes, sir.
Is this the only condition? या कोई और भी हो सकती है? Can you think of some other condition as well for which this is going to turn out to equal to capital N?
No, sir.
No. Okay. Anybody else? Teacher say. Seth? Seth says n equals 0. N to summation वाला variable है. Right? So Gul Hamid is sort of there. Okay, Jamshed says, how will this formula result in capital N when k equals r? How will this formula result in n when capital N when k equals r? Because when k equals r, this is e raised to power 0, and e raised to power 0, Jamshed is 1. Okay? And so this is 1, and you're summing 1 how many times? Capital N number of times, so that's just 1. Okay? On the right hand side as well, if k equals r, so this is 1 minus 1, but this is 1 minus 1 as well. Okay? So you have 0.0, so you need to work in the limits. You can apply L'Hopital's rule. You take the derivative of this with respect to k minus r and the derivative of this with respect to k minus r. I'll urge you to do that on your own, and you will find, of course, that in that limit, when you apply the L'Hopital's rule, in the limit this going to 0 and this going to 0, this turns out to be capital N. Okay? Go ahead and verify. Everybody. Go ahead and verify everybody. Okay? अच्छा, so question मेरा हारिस कह रहा है कुछ.
सर mod of k minus r हो सकता है.
Mod of
you can take negative values as well.
mod of k minus r आप क्या कह रहे हैं?
सर ये जो कंडीशन है आपने लिखी है
Yeah,
k minus r is equals to 0.
Yeah.
सर इसकी जगह mod of k minus r is equal to 0.
Yeah, but that's exactly the same as k minus r equals 0. ठीक है, 0 का mod 0 ही होता है ना. Those are not two conditions or more than two conditions. ये हारिस ने मुझे बताया था अभी, और सईद ने हाथ खड़े किया जी.
Yes sir, मैंने कहा था k minus r is equal to capital N.
Excellent, जबरदस्त. So actually ये condition जो है ज़्यादा जनरल है. So this is
periodicity की वजह से.
Any integer multiple of n. ठीक है, where m is an integer. Right, so technically speaking, it could either be 0, either be capital N, or 2n and 3n, and or minus n, and so on and so forth, because for every value of k minus r, which is equal to an integer multiple of capital N, this will turn out to be e raised by j 2 pi times some integer, which is always equal to 1. ठीक है? So technically speaking, यहाँ पे इस जगह पे थोड़ी सी गड़बड़ है. Right, so somebody should have picked up that mistake. Right, so it's not n of delta k minus r. Is actually there's another term here, okay, which is minus m times capital N. लेकिन बहरहाल, तो from here I'll move on and say this is the analysis equation, right? And this will now be the bread and butter of whatever we do from here on, which is this is the analysis equation that we're going to keep on using, and this is the synthesis equation. So this synthesis equation tells me that any periodic signal, a discrete time periodic signal, can be represented as a linear superposition of complex discrete time exponentials in this fashion, where a sub k's are spectral coefficients, or the discrete time discrete time Fourier series coefficients, which can be determined through the analysis equation, as you can see over here. Okay? Now there's an important point about the periodicity of the Fourier series coefficients. And one of the ways I can do it directly is by analytically is by just looking at this analysis equation and seeing if I, instead of k, I had a k plus capital N, I'll get that k thing back. Okay? So a0 therefore is equal to an, and a1 is equal to a of n plus 1, and so on and so forth. There's a periodicity, is a circular thing in the Fourier series coefficients as well, which actually does make sense because of the circular argument. ठीक है? अगर ये frequency यहाँ पे is 2 pi by n, and so this 2 pi by n corresponds to k equals 1, and the Fourier series coefficient corresponding to this is a sub 1, I know that this is the same harmonic as corresponding to a of capital N plus 1. Okay? And that's the same frequency, and therefore a of 1 should also be the same as the corresponding to k equals n plus 1, okay? Because of the circular thing. Okay? So AKs or uski jo frequency hai, they go hand in hand. I mean, they're pairs, right? So if A1 is a coefficient corresponding to the harmonic, which has a frequency of 2 pi by n, and a n plus 1 is the harmonic corresponding to the frequency 2 pi times n plus 1 divided by n. But since that frequency is the same as that corresponding to k equals 1, so a of n plus 1 must be the same as a1. Okay? And that's a sort of an intuitive understanding as well. So the bottom line is that Fourier discrete time things are slightly different than the continuous time case. And all of those differences are there because of the fact that the complex exponentials there's a periodicity in the frequency. There's a wraparound effect in the frequencies. The only unique frequencies that you have is over an interval of length 2 pi, which is from 0 to 2 pi ज़्यादातर, ठीक है. इसकी वजह Fourier series coefficients भी unique capital N होंगे और इससे वाले जो बाहर वाले intervals हैं वो सारी periodicity के अंदर शामिल हो रहे होंगे, ठीक है. So summary is this thing here. This is what our screen read. Hold on. So this is the summary that you need to remember, right? Which is if x of n has period capital N, this is the synthesis equation, this is the analysis equation, where the Fourier series coefficients are always periodic with a period of capital N. Okay? Because they're periodic, typically हम सिर्फ a0 से लेके a capital N minus 1 coefficient निकाल रहे होंगे, ठीक है. यहाँ पे कोई क्वेश्चन है तो मुझे बताइए, and otherwise I'll go ahead to the example. Okay, so let me do an example here. So example is quite straightforward. It says cosine 3 pi by 4 n plus pi by 2, and we need to determine the Fourier series coefficients. Of course, you can apply the analysis equation. I am not going to do that. Rather, I will just use the Euler's expansion. Ab iska period is capital N equals 8. That should be straightforward. This comes in from whatever we did in chapter 1. And then this is the expansion, Fourier series expansion, sorry, Euler's expansion. Euler's expansion ke baad, this is j 3 pi by 4, this is 3 times 2 pi by 8, this is minus 3 times 2 pi by 8. So a plus 3 is this thing here, a minus 3 is this thing here, and those are the Fourier series coefficients. Okay? But because of periodicity, a minus 3 is exactly the same as a5. Okay? Because the period is 8, right? So your final result is this. Okay? यहाँ पे मैंने एक वैसी alternate तरीका बताया हुआ है कि this is 3 times 2 pi by 8, and here this was minus 6 pi by 8. Why don't I just add 2 pi n to it? There's a slight bit of was a typo here. This should have been or the bracket should have been inside, and the plus here. Nevertheless, so this is 6 pi by 8 plus 2 pi by minus 6 pi by 8 plus 2 pi by n, which is plus 10 pi by 8. Okay? So therefore, यहाँ से एक और तरीका भी पता चलता है, जैसे 8 plus 5. Right? Any questions here? No questions? Okay, so writing that AK is this for K plus, why don't we write K equals 3? Okay, and the reason why is because I said that you need to determine the Fourier series coefficients only in the interval 0 to n minus 1. Okay, so I need to determine A0, A1 all the way up to A7. So these are the 8 Fourier series coefficients I need to determine, with the implicit understanding कि इससे बाहर ये Fourier series coefficients हमेशा repeat करते हैं. ठीक है? So within this interval from 0 to 7, A3 is half e raised by j pi by 2, A plus 5 is half e raised by minus j pi by 2, and that's it. इससे बाहर repeat करेंगे. That's an implicit statement. ठीक है जमशेद? Right. So आप अगर टेक्स्ट बुक पढ़ें थोड़ा सा, तो टेक्स्ट बुक में वो ये कहता है कि I mean this is plus 5 or plus 5 plus minus 8 plus minus 16 plus minus 24 and so on and so forth. I am not explicitly writing it out. I'm keeping that implicit here. ठीक है? Because I'm just saying कि जी इसके इंटरवल के अंदर ये Fourier series coefficients है, इसे बाय रिपीट करेंगे. Okay. And you should go ahead and try this. Try to drive the same result using the analysis equation. Try to do that on your own. You'll get exactly the same result. Okay. There's an exercise here. I may come back to this if we have time. So, Okay, so this is the second example. इसके अंदर typos से that I was happy that students who pointed it out, and in fact, if I go through the chat window जिसमें errors point करने हैं, there I think 8 unique students who already responded with the errors that they picked up, which is very encouraging. So at least some people are watching it very, very carefully. So इस वाले एग्जाम्पल में किसी को कोई मसला था या नहीं था? Right, so I've made the corrections in white. यहाँ पे for example ये missing था और यहाँ पे ये missing था. Any questions here? So this is just simple application of the analysis equation. So Muniba asked, how did I choose the interval? What interval? So from minus n1 to plus n1? Okay. So, all right. So remember, this interval has to be over any interval of length capital N, right? So I could have chosen, if I wanted to, interval from 0 to all the way up to here, n minus 1. Okay, so this is n minus 1 here. If I wanted to, मैं यहाँ से start करके और यहाँ तक जाता, and I would have gotten the same result exactly. There would not have been a problem, right? However, to make my life a little easier, right, what I do is, I just need to sum over one interval, right? And that interval has to be of length n. मैं जो है यहाँ से यहाँ तक कर लेता हूँ, right? So that I just make sure that I have capital N consecutive values that I'm summing over. And that way, this square wave that appears to me is going to appear as a continuous chunk of ones over and over again. Otherwise, if I 0 से capital N minus 1 कर होता, so then I would have had a summation from 0 to n1, and then from here to n minus 1. And that would have been a little bit more tedious. I mean, it would have been doable, but would have been more tedious. और मुझे change of variables करने पड़ते और कुछ उधर लेके आनी चीजें पड़ती हैं and so on and so forth. That would have been more tedious. This becomes easier क्योंकि यहाँ पे मेरे पास एक continuously ones जो हैं वो एक ही summation के अंदर आ जाएंगे, ठीक है? That's why I've chosen this interval from minus n1 to plus n1. Iman says, why is it not from minus n1 to n1 minus 1? Iman, n1 is not the interval. Okay? So can somebody else answer Iman? Iman says, why is the interval not from minus n1 to n1 minus 1? So कौन आंसर करेगा ईमान को? जी हारिस.
सर इंटरवल 0 से n minus 1 तक ही है, लेकिन जो इसकी वैल्यूज एग्जिस्ट करती हैं वो सिर्फ minus n1 से n1 तक है, बाकी के लिए फिर 0 है ना?
Exactly, good. So ईमान असल में ये यहाँ पे x of n ही था, right? और मैं यहाँ पे let's say minus n by 2 to plus n by 2 if there was minus 1 if there was even, if n was even, वो मैं सम कर रहा था. लेकिन I know कि the signal is 0 outside of this interval. The signal is equal to 1 only when small n varies from minus n1 to plus n1. So therefore summation असल में यहाँ से यहाँ तक जा रही है, ठीक है, which are capital N values. But within these capital N values, there are only these indices of n from minus n1 to plus n1 in which the signal is 1 and the signal is 0 outside of this interval, right? And therefore that does not matter. I mean, that's just plus 0, I don't care. So this is minus n1 to plus n1. ठीक है, Iman? Does that answer your question?
Yes, sir.
Right. So this is 1 here, and then I just make a change of variables. M equals small n plus n1. Yahan pe aaya. I just take this out, finite sum formula, and I get here. Now, honestly, agar aap, if you were doing a problem of some sort and you're just left with this expression, you just give me this expression, I would accept it as a correct expression. What follows up from uh, from uh, from here onwards is only a simplification into a nice form that you see. I mean, this is called a sync pulse or discrete sync pulse. Discrete periodic sync कहते हैं इसे, ठीक है? बाद में शायद इसके बारे में कभी बात करें. And this is just a simplification of that. Okay. So which expansion? Which right side, Rimsha?
This side only, where we have to convert it into sine, one step above. Can you explain this part?
This one?
Yes. Yes.
मैंने यहाँ पे है. So this is e to the minus j theta. ठीक है, whatever this theta is. ठीक है. Now this is a trick that would come in handy, वैसे by the way, in a lot of other problems as well. Maybe अगर इस course में नहीं तो बहुत सारी जगहों पे और. Which is this is 1 minus e raised by j theta. Okay, in order for me to convert this to a sine, I say, okay, why don't I take out as common factor e raised by minus j theta by 2. Okay, so this is theta by 2. This is this thing here divided by 2. So that's why it's n1 plus half. This divided by 2 is n1, and 1 divided by 2 is half. Okay, so e raised by minus j theta by 2 मैंने common ले लिया, right? So this is e raised by plus j theta by 2 minus e raised by minus j theta by 2, right? And exactly, this is exactly what I do with the denominator as well. So this is e raised by minus j theta. I take e raised by minus j theta by 2 as common outside. So this is theta by 2. Okay. So this is plus theta by 2 minus e raised by minus j theta by 2. Okay. So this is 2j times sine of whatever this is. This is 2j times sine of whatever this is. 2j is going to cancel with the 2j. And what you're going to be left with is sine of this divided by sine of this thing here. Okay. और बाकी चीजें सारी अब आखिर में कैंसिल हो जाती हैं. This cancels, all of this cancels.
Okay, sir. Thank you.
Right, and therefore this is what you get. But there's a slight bit of a problem when k equals 0. When k equals 0, the numerator turns out to be 0. The denominator turns out to be 0 as well. And therefore you can apply L'Hopital's rules era. I think that's what you were trying to do, or you just go back to seeing what A naught is. Right? And you see, instead of me doing that tedious task of applying the L'Hopital's rule, which I encourage you to do anyway, if you are running short on time and you just want to find out what A naught is, you just go back and see what A naught is. A naught is just k equals 0, ye cheez cancel ho jayegi, and you're just summing x of n, right, from minus n1 to plus n1. So this is 2n1 plus 1 divided by n. Okay, you're summing 1 how many times? 2n1 plus 1 times, and of course it's divided by n here. So this is what your final relationship is. Okay. इसको आप जो है, there's a textbook में आपके there's a visualization as well, which is कि जी for first harmonic sin लगता है sinusoid है, फिर second harmonic में add करता हूँ, फिर third harmonic add करता हूँ, fourth harmonic add करता हूँ, और ultimately it shows कि जी when you add up all the harmonics, you indeed get something which is a square wave. Okay, I encourage you to look at the visualization in the homework in the textbook. One of the things I want to ask is, are there going to be any convergence issues here? So what do I mean by convergence issues? So when we talked about the continuous time case, we said a continuous time periodic signal की Fourier series representation, if it exists, can be written as follows. Okay, so there was always this if it exists, right? And even for the if it exists, the convergence was in a very, very specific fashion, right? So for example, for the square wave that we talked about, वो Lagrange और Fourier का मसला ही ये था, difference of opinion ये था कि Lagrange said कि how can you equate a discontinuous signal to a sum of continuous signals? That was the entire disagreement on, right? And now we know that's actually true. I mean, at the points of discontinuity, both are not equal, right? So there's convergence issues in the continuous time case. यहाँ पे कोई convergence issues होंगे या नहीं होंगे? In other words, can I say कि कोई एक ऐसा periodic signal है discrete time में जिसकी Fourier series representation exist नहीं करती? Like, what do you think? Any thoughts? Okay, they don't have to be correct. Any thought? Would there be convergence issues in discrete time? जी वसीम.
सर अगर हमारा जो एक एक एक्सप्रेशन है उसके डिनोमिनेटर में अगर 0 आ जाएगा तब वो कन्वर्ज नहीं करेगा.
इसके डिनोमिनेटर में
जैसे हमने इस एग्जांपल में ए के का जो एक्सप्रेशन बनाया है उसमें अगर डिनोमिनेटर में अगर 0 आ जाए, लाइक जैसे दूसरे कॉलम के जो फर्स्ट रो है उसमें जो एक्सप्रेशन है उसमें अगर 1 माइनस ई माइनस एक्सपोनेंशियल माइनस जे के 2 पाई बाय एन अगर ये 1 के इक्वल हो जाए तो ये 1 माइनस 1 0 हो जाएगा, तो ये इन्फिनिटी हो जाएगा पूरा एक्सप्रेशन.
हाँ नहीं, लेकिन उस केस में देखें असल में ऊपर डिनोमिनेटर जो है वो भी न्यूमरेटर भी 0 पे पहुंच रहा है, राइट? तो असल में आप देखें आप निकल कहाँ से रहे हैं, यहाँ से चीजें निकल रही हैं, राइट?
जी बिल्कुल.
अगर यहाँ से चीजें निकल रही हैं, is this an infinite sum or a finite sum?
Finite.
If there's a finite sum, are there any convergence issues with finite sums? देखिए convergence के मसले आते ही तब हैं जब आप when you're adding
infinity से जा रहे हो.
You said something?
No.
Rimsha said something maybe. So it's the finite sum में there are no convergence issues, right? And if you go up above, you see वो simultaneous equations बनाई थी हमने सारी की सारी, right? There were n unknowns, there were n knowns, and you can actually show that all of the equations are linearly independent and therefore the solution will exist. Okay, so there are no convergence issues in discrete time, right? That's one of the nice things about discrete time, Fourier series में खास कर. Okay, there are no convergence issues. Okay, so that's a point that I wanted to make. All right. Any questions about this example? Okay. All right. So, बाकी चीजें जो हैं, this is something I'm going to very quickly go through, and the reason why I'm going to go through this very quickly is because the ideas here are very similar to the ideas that we've talked about in the discrete and the continuous time case. Properties हैं, linearity is straightforward, time shifting is straightforward. So x of n minus n naught results in the Fourier series coefficients being multiplied by this exponential, or ये वही form है, e raised by j k omega naught times n naught, exactly the same form. Conjugation in the time domain, may Fourier series coefficients become a conjugate minus k. Time reversal में the Fourier series coefficients are reversed as well. First difference is this, right? Multiplication property is slightly different. I've not done a proof here. Maybe you want to do it yourself. Which is if you multiply two periodic signals which of the same period in the time domain, in the Fourier domain, the Fourier series coefficients are convolved, but that's not just any convolution. That's something called just periodic or circular convolution. And the way this is different than convolution is that this sum is not from minus infinity to plus infinity, right? Rather, you're summing over one interval of the period. Okay, so that's one of the differences of the discrete time case with the continuous time case. Parsev's relationship may be, you're saying that the power in the time domain, so this is the power in the time domain per period, right? That turns out to be equal to the absolute squared sum of the Fourier series coefficients, summed over one interval. Okay, and that's the difference. They're summed over one period, if you will. Okay, period of length capital N coefficients. Okay, as opposed to the continuous time case, just where the summation was from minus infinity to plus infinity, right? And this is something you can try to. I think this is one of the end of chapter problems anyway. Conjugation symmetry, सारी की सारी चीजें वही hold करती हैं. If x of n is real, the Fourier series coefficients are conjugate symmetric. If real and even, AKs are real. If real and odd, the Fourier series coefficients are purely imaginary. Exactly the same thing that we've talked about earlier. Okay, Jamshed, let me do that in a bit. So Jamshed is asking, okay, what would be the Fourier series of discrete time periodic impulse? So just give me a moment. So frequency shifting is a property that I've done a proof of. Like in the time, continuous time may be applicable to, by the way. You read it in the textbook, although we did not explicitly talk about it in the recorded modules. So it just says, KG, if I multiply the discrete time periodic signal with this exponential, and this exponential is not just any exponential, this has a particular form. This thing here is some integer times 2 pi by n. That's the frequency. So some integer times 2 pi by n. If that's an exponential that I'm multiplying in the time domain, what happens in the frequency domain or the Fourier domain is that the Fourier series coefficients are just shifted by capital M, and the proof is here. Okay? Any questions here? Okay. So Jamshed has asked, what is the Fourier series representation of a discrete time periodic impulse? So what do you think that would be? Anybody else who's gonna venture an answer? So let's say x of n is summation m equals minus infinity to plus infinity delta n minus right. So this is an impulse train, right? इस impulse train की Fourier series representation क्या होगी? So what do you think the answer should be?
Sir, the n minus m n is equal to mn पे आपका होगा एक कहते हैं impulse होगा एक.
So the first thing is let's sketch it out. So does this impulse train look like?
n is equal to mn पे ना एक होगा impulse. mn पे होगा एक impulse.
एक impulse है
positive mn पे. जी.
Okay. So let me see. Razi? Razi? Can you tell me what the signal looks like? So who can tell me what the signal looks like? I mean, please, somebody raise a hand. नहीं वसीम कोई और हाथ खड़ा करे जी. जी ईमान.
Sir, an impulse at 0, n, 2n, 3n, and then goes on. And for on the left side,
Yeah.
minus n, minus 2n, and then goes on.
Good. Excellent. And इसके दरमियान में सारे zeros हैं. And as Iman said, there's a negative side पे भी सारी चीजें जा रही हैं. अच्छा. अब इसके Fourier series coefficients निकाल रहे हैं, right? This is the signal that's given to you, and the height of course is 1, right? So if I were to determine the Fourier series coefficients, अब और जिन लोगों ने हाथ खड़ी की तो उनको मैं पूछूंगा. So तुबा आपने हाथ खड़ा किया था. How do I determine the Fourier series coefficients?
सर हम फॉर्मूला यूज कर लेंगे.
Right, so let's use the formula. So formula is here. This summation is summation from 0 to capital N minus 1, and this is x of n times e raised to power minus j k 2 pi divided by n times n. Right?
यस
तो
सर.
ये क्या बनेगा? अब ये बताइए मुझे.
एक्स ऑफ एन की जगह डेल्टा एन माइनस एम एन पुट कर देंगे और फिर एन की जगह एन माइनस एम एन आ जाएगा.
Okay. I mean, there's you see यहाँ पे आप जो है, okay, that's something you could do, but I would rather make it easier in the sense कि जी I am summing over the interval 0 to capital N minus 1 only, ठीक है? So my summation interval क्या है? Summation interval यहाँ से यहाँ तक है, यहाँ से लेके just behind the next impulse.
यस सर.
ठीक है? इस पूरे के पूरे इंटरवल में x of n कहाँ पे मान होता है?
0 पे सर.
सिर्फ 0 पे. बाकी सारी जगहों पे क्या है?
0.
0 है, right? So फिर what should the summation be?
1 over n e raised to power summation ends from 0 to n minus 1 into e raised to power minus j k 2 pi n over n.
Okay, लेकिन अब ये देखिए, अब आपने जो मुझे कहा है ना वो कुछ और बनता है.
नहीं सर, ये 1 हो जाएगा, ये पूरा 1 हो जाएगा, तो ये हो जाएगा n हो जाएगा, तो 1 आंसर आ जाएगा.
क्या?
इसका आंसर 1 हो जाएगा, ये पूरा n हो जाएगा, कैपिटल N.
Okay, so here's the correct answer. So x of n is 1 only when n equals 0.
Yes sir.
X
तो
of n
फिर
is
जब
1 only when n equals 0. For all other values, x of n is 0.
Yes sir.
Okay? Or
Yes,
for
sir.
that matter, आप ये कह सकती हैं, चलिए मैं इसको एक और तरीके से लिख सकता हूँ. Within this interval, the signal is just delta n.
Yes sir.
तो आप ये वो impulse की sampling property ले लें, right? या
Yes,
you
sir.
see, this is only for n equals 0. जी फरासत, you want to say something?
जी सर, मेरा सवाल ये था कि अगर एक ही टाइम पीरियड में मल्टीपल इम्पल्सेस हों तो और डिफरेंट एम्पलीट्यूड्स के,
Yeah.
तो सर यानी कि डिफरेंट शिफ्ट्स पे मल्टीपल एम्पलीट्यूड्स वाले आप एक ही टाइम पीरियड में आ रहे हैं
Yeah.
impulses. So will you just simply add them separately into that one time period?
Exactly. Farasat, let me do another example after this, which can answer your question. Okay? Acha, yeah, let me just wrap this up first, and then I'll try to modify this problem to answer your question. Okay? Acha, I claim this is just 1 by n. Right? Why is this 1 by? Everybody sees that? Ji Hassan?
So because because it's the sampling property,
yeah,
it would be just 1. The summation would be just 1 and 1 plane.
Good, Hassan.
So this is also just a square wave with n1 is equal to 0.
Yeah.
So this whole the x of n is just a square wave with n1 is equal to 0. We get the same answer.
Okay, excellent, Zabardast. That's something I did not think about, by the way, and that's very, very nice. So let me answer the sampling property first. So sampling property say I can get this equal to 1 by n, right? So I know for a fact that this thing inside the sum is equal to 1 only when n equals 0. तो ये n equals 0 वाली टर्म्स बचेगी, बाकी सारी की सारी n वाली टर्म्स है 0 हो जाएंगी, ठीक है? और n equals 0 वाली टर्म्स क्या है? This is n equals 0 here, this is just e raised to power 0, this is just 1. So this summation just turns out to be equal to 1, which is 1 by n. Another very important or interesting point that Hassan raised is if I just go back to the example, इससे पहले वाली जो थी वो इधर नहीं है, इससे पहले वाली थी जिसमें square wave थी from minus n1 to plus n1. If I just plug in n1 equals 1 there, you will get exactly the same result. Go ahead and verify this. ये हसन आपने verify किया या intuition से बोला है?
Yes, sir, I verified it. It's n1 is equal to 0.
Sorry, n1 equals 0. Exactly. When n1 equals 0, that square wave thing that you saw, example that you saw earlier, would reduce to this thing here. Okay? So the Fourier series coefficients of a train of impulse is 1 by n, just like the continuous time impulse case. Okay? So that's correct. Okay? अच्छा मुझे एक इसकी implication है वैसे जो बड़ी, अब ये Fourier series कहता क्या है, इसका मतलब क्या है, meaning what? So means the following. So Fourier series representation क्या कहती है कि x of n is equal to summation k equals 0 to n minus 1 a sub k e raised to power j k 2 pi by capital N times n. And for this particular example, the left hand side is this thing here. Okay? The right hand side from my evaluation, a sub k is 1 by n, and this is just summation k equals 0 to n minus 1 e raised to power j k 2 pi by capital N times n. Okay? So I've just written down what the Fourier tells me, and the Fourier tells me कि यार ये जो चीज़ है ना can be written down as a superposition of these exponentials. That means this must be equal to this. And then you're scratching your head here and saying कि यार ये क्या बात कह दी इसने? Right? This is what you, so is this saying that the train of impulses actually can be written down as a summation of these exponentials? Because that's what Fourier is telling me, right? And this requires some more thought कि जी वाकई Fourier सही कह रहा था या नहीं कह रहा था. I mean, go ahead and try to see कि यार वाकई is this true or not? Can anybody see or कि जी why is this true or can it और है कि नहीं यार ये हो सकता है गलत कह रहा हो Fourier? ठीक है, इसके बारे में सोचें जरा कि why is the left hand side equal to the right side, or rather more precisely, why is the right hand side equal to the left hand side? Go ahead and try to verify. This is actually something that we've done already.
Oh, sir?
Yeah, Farasin?
Is it because of the sampling property of the impulse function? Sampling would snap the exponential function into the specific time shift, and does get a summation.
It has, I mean, does not have to do anything with the sampling property of the impulse functions or impulse trains or impulse functions. आप बस सिर्फ right hand side को देखिए और ये देखिए कि ये actually summation है of sinusoids.
अच्छा सही ठीक है सर.
ठीक है, और वो जीरो होती है, राइट? अब हमने अभी इससे बात कर रहे आते हैं, right? Except when certain things are satisfied. Except for example, हाँ बताइए.
When n is equal to 0, I think.
Yeah, when small n equals 0, ठीक है? और कौन सी values? सिर्फ n equals 0 के लिए non zero है. What if small n equals capital N? Then it's still non-zero. ठीक है? What if n equals 2 times capital N? Then it's still non-zero. ठीक है? So something to think about. I mean, at the end of the day, I mean, when you think about it, you're going to see everything makes sense. Everything makes sense. I mean, the Fourier analysis makes perfect sense. ठीक है? अच्छा. Let me now try to. फरासत आपने पूछा था ये दो impulses वाला.
जी सर.
Yeah. So उसकी एग्जांपल ये ले लेते हैं. Right. So x of n is equal to summation m equals minus infinity to plus infinity delta n minus m times capital N plus m equals minus infinity. So let me plus infinity करते हैं. Delta n minus m n minus 1. So how do you determine the Fourier series coefficients for this signal? So फरासत आप भी चलें, आप नहीं, कोई और मुझे बताएगा. मैं नीचे से स्टार्ट करते हैं. शहरोज. Yes. Shahroz, can you venture an answer? So Hassan ne sahi, so you're there, Hassan, is linearity. That's something you can use. So let me see if Shahroz can venture an answer here. They don't have a mic. Okay. So who else has a mic? नीचे से देखते हैं. Tanzeel?
Yes, sir.
हाँ जी, आप बताइए. Can you help me here?
So दूसरा जो है shifted version है उसका 1 से, तो shifted version का अलग से निकालने और दोनों को separately add कर linearity use कर लें.
Good. ठीक है. So you use the linearity property here. ठीक है. So आप ये कहते हैं, मैं इसे एक और तरीके से भी करके दिखा दूंगा. Right. So you say कि यार, I'll split it up into two. Both of them have the both of them have the same period, right? Which is capital N. So this is the first signal. This is the second signal. इसके Fourier series coefficients क्या हैं? 1 by n, which we've done already. ठीक है, in the previous. इसके Fourier series coefficients क्या हैं? This is 1 by n, and then shifting property. Shifting property क्या है? This is e raised to power minus j k 2 pi by n times n naught, but n naught is just 1. So therefore, इसके पूरे के पूरे Fourier series coefficients जो हैं, would just simply be ak plus bk. So this is 1 upon n, 1 plus e raised to power minus j k 2 pi by n. ठीक है. So Farasa, this is your answer.
Sir, इस पे एक और question है sir बस.
Yeah.
So they both have the same period in this case. What if they have different periods और उनका एक overall जो fundamental period उससे different हो जाएगा?
Excellent. Then you're not in a trouble, लेकिन you'd have to do something extra. And I don't want to address that here, but so
Sir, can I give my own
interpretation? Yeah, of course.
Interpretation.
हाँ जी.
Sir, तो मैं उसमें सोचा था कि इसके Fourier analysis लग जाएगा linearity की वजह से it will be split, but उन दोनों का fundamental time period एक ही रहेगा फिर उसकी वजह से, तो वो दोनों पे एक ही time period लगेगा. वो मुझे इससे वो मिली थी.
So let x1. So let me write this out here for everybody else to think about as well. Let x1 of n be periodic with period n. और इसके जो Fourier series coefficients है ना, with respect to the period n are AKs, right? And then let there be another signal x of 2 of n, which is periodic with period 2n. उसके Fourier series coefficients b sub k's हैं, right? I've gave you another signal which is z of n. चलें इसको मैं x of n कर देता हूँ. X of n equals x1 of n plus x2 of n. Okay, and the question is के determine Fourier series coefficients with respect to as a function of AKs and BKs. Now here you cannot just simply apply the linearity property. Not either frequency shifting property being lag sakti Jamshed, right? This has a little bit to do with one of the challenging problems, a little challenging problems that I threw at you in the last session on Thursday for the continuous time case. मैं कह रहा था कि एक सिग्नल को मैं लेता हूँ, उसको कंप्रेस कर देता हूँ, तो फिर बताएं कि उसकी Fourier सीरीज रिप्रेजेंटेशन क्या बनेगी नई. ठीक है, तो why don't I let you think about this and then somebody get back to me if they have an answer. ठीक है, जिकुल हमीद आपका क्वेश्चन है.
सर हम x1 के फोरियर सीरीज कोएफिशिएंट्स 2n के लिए भी तो निकाल सकते हैं ना, 2 कैपिटल n.
Exactly, that's what you would have to do. लेकिन वो 2n के लिए जो Fourier series coefficients निकलेंगे, that would be related to the Fourier series coefficients a sub k's. How are they related to a sub k's? That's something I want you to figure out. When you are able to find that relationship, इसके Fourier series coefficients with respect to 2n क्या होंगे, then you can apply the linearity property rightly.
तो सर फिर दोनों का फंडामेंटल पीरियड तो सेम हो जाएगा, x1 का भी और x2 का भी.
Yeah, 2n हो जाएगा.
फंडामेंटल तो फिर डायरेक्ट हम लिनियरिटी प्रॉपर्टी यूज कर सकते हैं ना.
कर सकते हैं, लेकिन फिर आप मुझे बताएंगे कि इसके नए Fourier series coefficients a sub k's के फंक्शन में क्या होते हैं. वो a के नहीं रहेंगे
जी, वो तो चेंज होंगे.
वो चेंज हो जाएंगे. वो क्या किस तरह चेंज होते हैं, that's something for you to answer me.
थैंक यू.
ठीक है, अच्छा. So let me see के can somebody tell me क्या किस तरह चेंज होंगे अगर मैं if I were to evaluate the Fourier series coefficient not respect to n but respect to 2n, ये किस तरह चेंज होते हैं. कंटिन्यूस टाइम में ट्राई किया था किसी ने, मैंने चैलेंजिंग प्रॉब्लम को छोड़ा था. Did somebody try it out? Okay, so I'll leave this off for you to try it out as well. We're out of time and we're almost done anyway. So this is just a simple example of linearity. So you are required to find the Fourier series coefficients for this. We just imagine as being equal to the square wave plus this constant DC. इसके हम निकाल चुके हुए हैं, which is here from the previous example. BKs are this, and you just add them up, and this is the result that you're gonna get. Okay, so I'll stop here and open the floor for any questions you may have about this or anything else. Or सबसे पहले चलें, if there are any questions about the content that we covered today. Okay, or anything else?
Sir?
Said, can you go ahead?
सर मैंने एक छोटी सी बात पूछनी थी.
जी पूछें.
सर कॉन्टिन्यूस में जब हम स्क्वायर वेव बनाते हैं तो हमें गिब्स फिनोमेना हम ऑब्जर्व करते हैं, तो डिस्क्रीट टाइम में ये फिनोमेना तो नहीं ऑब्जर्व होगा ना?
नहीं होगा, क्योंकि डिस्क्रीट टाइम में कोई कन्वर्जेंस इश्यूज नहीं होते.
ओके सर,
ठीक है. अच्छा जी, और कोई क्वेश्चन? रिमशा आप कुछ पूछ रही थी.
Yes, sir. Can you please tell how we got dk 1 is equal to 1 when k is equal to 0 and 0 when k is other values?
अच्छा ये मुझे कोई और बताएं. So the question is, why is this the Fourier series representation of this constant signal? रिमशा कंटिन्यूस टाइम में अगर आपको डीसी सिग्नल दे दूं तो उसकी क्या Fourier सीरीज रिप्रेजेंटेशन होती है?
So DC signal.
Yeah.
So it will be that particular height, that is 1 for some value of k, which is generally 0.
Generally,
and yes.
I mean, it's always 0.
Yes, and 0 otherwise.
Or E naught equals 1 and 0 for all other values of k. The Fourier series coefficient is 0, right? Continuous time mein.
Yes.
So how do you get that? I mean, why? How is this any different than that?
Sir.
I mean, this is just a DC. Right? It just stays 1.
Okay.
Right? So this is x2 of n. X2 of n equals 1. Right? So this is 1 times e raised to power j times 0. And you just compare this with the synthesis equation. You just compare this with the synthesis equation, you get this as a naught equals 1. Again, all others are zeros.
Okay, sir. Thank you.
Ji Farasat.
Sir, this is a little unrelated to what we're discussing right now, but Minister, here पूछना था कि the assignment that we're doing, it's directly related to chapter 3 या chapter 4 or 5 के भी इसमें concepts है?
नहीं, 3 है, chapter 3.
ठीक है.
Chapter 3, yeah. So Jamshed says, what if the period n is very large? When the period n is very large, the Fourier series actually becomes equal to something called the Fourier Transform. Okay? And we're going to do this thing for the continuous time case first, starting next week, and then the discrete time couple of weeks from now. ठीक है? चलिए, अगर एक सिग्नल का पीरियड बहुत बड़ा है, तो I say that signal actually converges to that becomes an aperiodic signal if the period goes to infinity. Okay, so that's all I want to say. एक और जो चीज वैसे just for your consideration, we're going to have a quiz soon. Okay, I know that you have a Circus 2 quiz on Sunday, right? So signals का quiz भी is going to be very, very soon. So we're going to talk to you and try to schedule it. ठीक है? हो सकता है Sunday को ही हो. Okay. चलें जी. I'm going to stop here. अगर कोई और मुझसे वैसे कुछ पूछना है, not just about signals or anything about life, how's life, how's studies, how's life in lockdown?
It's good, but a little tough.
A little what?
A little tough.
Little tough? In what sense? Being stuck at home?
Not exactly, sir. My family is actually in Abu Dhabi, so right now I'm living in a guest house.
Oh,
the flights are closed.
Achha, so you're not been able to travel?
Sir.
अच्छा, नहीं, I can imagine that stuff. So आप लाहौर में ही हैं फरासत या?
नहीं सर, मैं पिंडी में एक एयरफोर्स वाले मेस में रह रहा हूँ.
अच्छा, ठीक है. चलें, I wish you the best.
Yes, sir.
I know it's not easy. I mean, especially when you're away from family. So this too is going to pass. Okay, then this 2 shall pass. हाँ ठीक है जी. Or anybody else? How's life? So let me stop recording first.